In this lecture, we see what is Newton's law of cooling. Newton's law of cooling was proposed by Sir Isaac Newton in the early 18th century. Newton observed that the rate at which an object cools depends on the difference between its temperature and that of its surrounding. He formulated this as a first order differential equation, establishing one of the earliest connection between heat transfer and differential equation. So we can say that this is the first thing, our first mathematical models based on the differential equation of heat transfer. The law laid the groundwork for the development of thermodynamics and heat transfer theory, later explained by scientists like Fourier and Clausius. So this is about history of the Newton's law of cooling. Now let us see what is Newton's law of cooling. The rate of change of the temperature of a body is, is proportional to the temperature difference between the body and its surrounding medium. So, the rate of change of temperature of a body is directly proportional to the temperature difference between the temperature of the body and the temperature of the surrounding. Let theta be the temperature of the body at any time t and theta 0 be the temperature of the surrounding at that particular time. Then according to Newton's law of cooling, d theta dt, which is equal to minus k times of theta minus theta 0. So theta minus theta 0 is the difference of the temperature of body and temperature of surrounding. This k is proportionally constant, so we can also write down this can be written as d theta dt is proportional to theta minus theta 0, which is the difference between surrounding temperature of the body and the temperature of surrounding. Now, if we remove the proportionality sign, we write down minus k. So, why we have written minus k? Because when the time will increase, suppose there is a water which is boiled up to 100 degrees centigrade. So now if this water or this water will be cooled down, then definitely its temperature will be decreased. It may be 99 degree, then 98 degree, and so on. So what we can say that when the time will increase, the temperature of the body will decrease. So therefore the minus sign appear over here. But sometimes suppose if we have a thermometer. Suppose the normal temperature of in the thermometer is 37.4 degrees centigrade, or we can say that 98.5 Kelvin, Fahrenheit, sorry, Fahrenheit. So if we keep this thermometer in the hot water, there is a hot water. If we keep this thermometer in the hot water, so definitely the temperature of the thermometer will be increased. So at that time, when time will increase, the temperature of the thermometer will also increase. So at that time, we don't put minus sign over here. So minus sign represent when the time increase, then the temperature of the body will decrease. Where K is proportionally constant, here minus sign shows when time will increase, the temperature of the body will decrease. But if the when time is increase and also the temperature of the body will increase, then instead of minus sign, we put the plus sign. Thank you.